In this video, you're going to be building Uniswap clone on the Ethereum blockchain using Infura and NextJS. You will be able to convert your Ethereum coins into custom ERC20 tokens that we'll be building throughout this build. That said, let's get straight into the video. All right, ladies and gentlemen, welcome back to another build. Today we are building Uniswap, as you can see in the title. So while you're down there looking at the title, go ahead, click that first link right below that, because that's going to take you to this very page where you're going to go ahead and sign up for Infura. After hitting the sign in button, you put in your name, email. You don't put in your name, you just put in your email, and then you put in a password, and then you go ahead, click sign up, and then verify your email, whatever. Answer those few questions. It doesn't really matter. It's just for analytics, but like you can just select engineer and solo freelancer, whatever applies to you. And once you're good there, you go ahead, hit submit, and then straight away, you're gonna go ahead, get started with a project. Now, for network, you wanna go ahead and select Web3 API. The reason is, there's a bunch of chains that one particular thing supports. And then for name, you can put in like whatever. I put here production, but like you can just put in Uniswap, whatever. Once it's done, hit submit, and go ahead, and that's it. That's basically it. You're done, you're in. You're good, you're set. Now, there are all your projects, which is probably only one. And if you already have an account, just go ahead, sign in, and basically you could have skipped this entire part. That said, let's go ahead and set up Metamask. Okay, next up, you wanna go to metamask.io/download. Now, once you're there, you can just go ahead and click that big blue button that's going to take you to Chrome Web Store. And by the way, this build is only going to be working on Chrome or whatever browser that supports MetaMask, but we just suggest Chrome. Hit add to Chrome, go through that, add extension, whatever. And then once it's done, it's going to pop open a brand new website for you, which is just like their configure page. And if you already have MetaMask, like once again, you can just skip ahead a couple of minutes. But if you're new, click agree, and obviously read that. We all know that's important, and everybody reads that. Privacy policy is the most important thing you will ever read in your life. Not legal advice. Now, if you happen to have a new computer, you can just import your previous wallet over there. But if you are brand new, you can just click create new, add a password that you will have to remember. Again, read the terms of use, and then create a new wallet. Now, I highly suggest you go ahead and watch that video, because that's going to explain to you in thorough details on how you can keep your 12-phrase mnemonic safe. But in short, keep it safe. Because if someone steals it, they will have full access to your wallet. Now, quick tip. You want to use separate wallets for development and for your own funds, and then never share any kind of detail where your money is at, and then only share details of wallets that you don't mind that get compromised. Now, here's your security recovery phrase. This is the absolute key. If it gets lost, you're done. Like for real, without exaggeration. So keep it a secret. With that said, though, you're going to have to go ahead, copy this whole thing, hit next, and then you will have to verify that you have that. You can just copy paste it in there and you're good to go. Now, once you hit confirm, MetaMask basically takes that as your confirmation that you are aware of everything that I just said, and all the terms of use and everything that they prompted you. So once you hit all done, you're good to go. There is your MetaMask. Now, one more thing you want to do is, because you only have access right now to the Ethereum mainnet, which obviously is a ton of money, and you don't want to use that, click that show hide right there. Scroll down all the way where you can see show test networks. Turn that thing on, and then turn on show conversions on test networks. That will basically show the dollar amount of every single Ethereum in your wallet, which is just a nice touch. And then basically you're good. Now, if you scroll back up and then click the selector, there are all your test networks. Now, in this build, we're going to be using Goerli, so you might as well go ahead and check that off, or you might as well go ahead and select that. That said, let's go ahead and get started coding. Now, if you're familiar with us, you know that we have our own CLI tool that makes your life easier, and you want to go ahead and to use that, you want to type in npx clever program, and if you don't have it, it will have to install itself. I also recommend you add a @latest at the end so that you get the latest version of it, and it will get it, or it will update itself. But regardless, just put in your email address and then put in your name. And then at the time when we shot this wasn't the latest version, but right now we are supporting type search. So if you start typing Uniswap, it will basically just narrow down the list, and then you can just hit return, select that one. So that's going to be something that's going to help you. So anyways, it's going to run a couple of scripts, and it will install all the dependencies and everything for you to get started, and then open up your VS Code in that specific project. So you can just sit back, relax, get up a coffee, whatever. And as you can see on my screen, that's what's happening there. Now, I already opened this guy up. That is the project that we're going to be building on top of. And for you to spin it up, I'm just going to zoom in a little bit just so you can see it better. What you can do to spin this up is cd into uniswap-apt, cd as in change directory, by the way. And then in there, you just type in yarn dev, npm run dev or something, but I just recommend you use yarn. Anyways, once it's good to go, you open your local host up, and there is your project. That is your starter project that we're going to be building on top of. And there you go. Let's go ahead and start setting things up. Now, to make things extremely easy for you, we recommend you use Truffle extension in your VS Code. So you want to go ahead, search for Truffle for VS Code, install that guy, and basically they have an integration with Infura, which we're going to be using today. So that's a pretty good one. And once you're there, open that little Truffle icon on the left-hand side. You can go ahead, click create new network, and that will, and then select Infura service, and then you can go ahead, click sign up, and that will just take you to Infura. And once you connected the two services, it will prompt you to select the project name. Now you can either type it in there, or sometimes it like shows it up. Oh, because we actually you can just create a brand new project. So just type in Uniswap, and that's going to be the new name of the project. However, if you want to connect it to an already existing project, you can just hit connect to network instead. And then that will show you the drop down, which will enable you to select your existing project. Now, once you typed in, we recommend you use public just for easiness, just to make things easier. And then there you go. There is your project. All right, for this next step, we recommend you use remix.ethereum.org, which is, by the way, an online IDE just to create smart contracts. And I'm going to slow down a little bit because this is where things are getting a little advanced, and these are things that might be new to you. Now, if you watch a couple of my other tutorials, I might be using the VS Code extension. For this tutorial, we're going to be using this. So if you want to see a familiar thing on your screen as you see on my screen, you might as well use Remix IDE in the browser. Now, to generate a new workspace, you can either leave it on the default or you can just generate a new one. But to generate a new one, you can click that little plus icon and then just name it the way you want to. Template doesn't matter. And in your contracts, what you can do is right-click new file and then just name it uniswap.sol. Now, in this file is where we are going to write most of our contracts. So starting off, SPDX license, identifier, MIT, that you just need it. Don't question it, you just need it. If you write MIT there, basically it's an open source license, anyone can use it, and you're not liable for anything that happens, whatever you write in there. The more you know. Now, you have to specify the version of Solidity you are using. I see so many people trip up on this. You don't want to mess that up. Type in 0.8.16. That was the latest one when we shot this tutorial. What you will need to import, though, is something from OpenZeppelin. Now, they have template contracts, and you're going to be importing the ERC20 contract token. And this is basically going to, let's think of it as like a NPM package, but for Solidity. We're going to have two contracts in this file, if I'm correct. First contract is going to be, we're just going to name it custom token, and it is going to be child of ERC20. So it's going to inherit everything, and we're going to have a constructor in there. Now, that constructor is going to require two inputs. One of them is going to be a name, and one of them is going to be a symbol. Now, both are going to be strings. And then this is going to be, you're going to obviously pass it into ERC20 because that has a constructor. Now, ERC20 has a _mint function built in. It comes with the import, so you don't have to import it separately. Now, minting requires a few more things. Minting requires a wallet where all the tokens are going to be minted to, and then an amount. Now, what is happening here is we want to mint 1,000 of those tokens. However, And this is something that I'm going to say a bunch of times during this tutorial now. I've said it many times. In Solidity, the only currency that is accepted and the only currency that Solidity works with is something called Way. Now, that is basically all your first contract. So congratulations, you just wrote your first contract that will mint a bunch of ERC20 custom tokens into your wallet. Now, you can go ahead, close that artifacts thingy. If you have auto compile enabled, that's just going to go crazy, and it will keep compiling your contract and make sure everything is good to go. So as long as that check mark on the left hand side is present, you're good. And with that said, let's start typing up another contract, which we will call Uniswap, and that will handle all the conversions and everything. Now, that will require another constructor, and inside that constructor, we're just going to start straight away with a for loop. Now, custom coin that we're going to create, in this case, coin A, coin B, coin C. We're going to start from 0 and go all the ways to tokens.length. Now, what is tokens? Yes, good question. We're going to figure it out in just a second. Don't worry about it. There it is. It is going to be an array of tokens, or it is going to be an array of strings. It's basically just the names of every single token. It's not super creative, but it gets the job done. And it doesn't go all the way down to all the fanciness. You can use this. You can just rename it. You can even call it Coca-Cola if you want to. It doesn't really matter. We just wanted to go with this because it's simpler, easier to follow, especially if you're a beginner. All right, so we're going from 0, and the max is going to be the length of that array. You can put in 5, 10,000, 2,000, 3,000, however many random coins you want to. And then just like usual, just like in JavaScript, you will increment that I variable, which is going to be the index. Now, here, you're going to go ahead and create a new instance of custom token. You don't have to import anything. You don't have to do anything. We're just going to create a new instance of it, meaning it will invoke the constructor. So you're going to see that in action in just a little bit. So as you can see, we are passing in 2 items to that constructor, which is tokens I and tokens I. It's literally the same thing. And if you look back up to line 7 on my screen, I don't know which line is on your screen, but on my screen, it is line 7. It requires 2 inputs. So that's what we are putting in here, meaning that the coin name and the coin symbol in this case is going to be the exact same. Again, if you're advanced, you can do some tricks with it, but I recommend you just stay with this for now. It will get the job done perfectly. We want to definitely save this new token that we just created right now in a mapping, and we're going to set that up in just a little bit. This mapping later on is going to enable you to fetch all these coins way easier than otherwise would be. So let's go ahead and set up that mapping. So for that, we need to use the keyword mapping, and it's going to be it's going to map a string to an ERC20 token. All right. It's going to be public, meaning anyone can use it. So there's your mapping that we're going to use. And then we will set up an ETH value. And that's just, once again, to keep things simple. This is a beginner tutorial. We're keeping things simple. If you haven't heard of Solidity before, you're in a good place. So we're going to set up a ETH unit, an ETH value, which is going to be a uint. What is a uint? It's a number. And again, I'm going to refer back to the statement that I made just a minute ago. Everything is stored in Way. So we're going to convert ETH unit to Way. And if you save this website, by the way, eth-converter.com, that is eth-converter.com, that will be helpful for you later on. So if you put in any kind of Ether value, in this case, it's going to be 0.000, that is 0.0001. Yeah, I'm not going to say any of the other numbers. Just copy that. That's going to be your Way value that we'll be saving there. So that's going to be your base Way value. Save it there. It will be useful later on. Don't worry about it for now. Just do as is, and then it will all come together. Now, if you select that last option on the left-hand side, now we're going to go ahead and compile and deploy this contract that we just built. Now, I also have auto compile enabled, so it's automatically compiled, but you will have an option to do so if you need to. And then there is that big orange deploy button. Click that, and down there under deployed contracts, it should show up. And those are the two functions that are available right now. And those are coming built in with ERC20 and everything and the mapping that we created. Now, little explanation here. When you deploy a contract, the constructor runs immediately because in the constructor, we have the for loop that will immediately deploy all 3 coins. So you don't even have to worry about that. And so what you can do is here fetch all the coins that were deployed. So if you put in coin A, which is just of the first coin, it will return the address of that coin. And so that's what we just implemented. So mappings works like that. You got to pass in a string and it will return an ERC20 address. So that's what you see there. And then for tokens, that is on my screen in line 13, that is the array. So you can fetch each and every single element like that. And if you get these results on the left-hand side after you deployed your contract, congratulations, time to move on. All right, now you have your custom tokens, perfect. Each of them are deployed and minted, 1,000 of each. But how do you verify that? You need a function that returns the balance of each coin. So you want to go ahead and get started creating a new function inside your second contract, and we'll call it getBalance. Now, this will have 2 inputs. One is the token name, and the second is an address. What's happening? You want to get a balance, all right? So you need the wallet address, which holds potentially that token. And that's going to be the address. And then you want to pass in the token name. So let's say I have a wallet which has a random address and I have coin B. So in that case, I will pass in coin B as the first argument and I will pass in my wallet address as the second argument. And all I expect to see back is just a number of how many ether or of how many coin B do I have in my wallet. So it's going to be a public function which will return a uint, as I said. And all it will do is just go to the mapping and then pass in the token name. So far, all it would do is just return an address. However, once you got that address, you want to call a balance of function. And this is something that is coming from ERC20. So this is part of the standard. And there you're going to pass in the address. So it's going to be my wallet address that's going to go in there. So what it will do under the hood, it will retrieve the token address. So we'll know that coin B has this and that address. And we're going to check that at that address, my wallet address, a lot of addresses I know. So at that coin address, my wallet address, how much the balance of that is. Scrap that. So this will return that my wallet that has the second address that will return the balance of the first coin inside of my wallet. So let's go ahead and deploy this new contract. And actually you can see all the instances. You feel free to keep removing it, but you can keep it. That's fine too. Again, the constructor has run immediately, so we're not going to check that. But you can pass in coin A right there to check how much coin A in your wallet, and then you want to pass in your very own wallet address. Now, you can get that from there, from the account, because it is not actually connected to your Metamask yet. It is Remix ID's own built-in environment, so it gives you a bunch of test tools. So once you pass that in and hit call, I'm gonna pause this here for a second, and you should pause. Guess how much of the coin do I have in my wallet? Invalid address. Perfect. That's not what you guessed. Am I right? Okay, that's just because I have those quotes there. So let's just remove it. It's an address. It's a different data format. I know it's annoying. I can get around it. I make mistakes all the time. Remove the quotes, call it again. So there you go. Pass that in, pass the address in and call it. And if you guessed 0, you're good. And with that said, let's keep moving. All right, let's just create a function that will return the coin name every time you pass in the coin name. It's precise. So you want to have a function that will return a string, and it takes in a string and it will return the coin's name from the mapping. So there you have it. You want to type in token instance map, token name dot name function. And there you go. If you go ahead and redeploy the contract and then go ahead, test this out, and then type in coin A, it will return coin A. All right, so let's build a function that will return the custom coin's address. So we can fetch a bunch of things with that just by passing in the name. So let's do that. All right, so we're gonna get started by just starting a new function. We'll call it just get token address or whatever. And it will have one input, which will be a string, and it's gonna be token name. And then it will return, obviously, an address. And then all we're gonna do is just call the address function on the token instance map and then pass in token name. So literally we're gonna use the mapping that we already have, pass in the name, and that'll return the entire thing. And we're just gonna need the address of that specific contract. Okay, so let's go ahead and deploy that and let's see if that works. So if I just type in coin A and then hit that, there's my address. That's working perfectly. Let's go ahead and get started swapping stuff because this is where like the real deal is gonna get started. All right, now we are going to get started swapping ETH to custom coins. And this is where the real meaty stuff is happening. So you can come back to this if something is unclear. All right, so let's just go ahead and create a new function. It's gonna be, create a new function. It's gonna be actually a pretty simple one. So we're gonna call it just swap ETH to token. And it will have one input. It's gonna be a string, that's gonna be the token name. So basically what's gonna happen is you're gonna send X amount of ETH to the contract and the token name. And that's it. And then the rest is gonna be handled by the contract. This is gonna be a payable function because we'll need to send money all over the place and it will return a number of how much was actually converted. We're gonna need to have a couple of variables here. We're gonna be saving the input value, then we're gonna be saving the output value, which is gonna be input value / ETH value. And if you look up to my line 15 on top of the screen, that's where my ETH value is at. And then we're gonna need to make it an 18-digit way thing. Remember, that's a solidity thing. And then we're gonna need a requirement here. So we're gonna need to make sure that the transfer actually happens, all right? So we're going to need to transfer from the coin that the user is acquiring. We're going to need to pass a couple, however much we need to, basically the output value amount. We need to transfer it to the user's account, all right? So that's how we're calculating the whole thing. And so and then we just return the output value, which will just tell the user, hey, this is how much you actually got for your money. And so there's the ETH value that helps us once again convert between ETH and the custom token. And you're going to decide which token you want to get. And then you're just gonna pass it, turn it into Way, transfer it over. And if that's good, you're ready to go. All right, so let's go ahead and actually test this out. So I'm gonna deploy it and let's see what do we got. Because of the constructor, I already have access to a bunch of ETH and all these tokens. So those are already there. So let's go ahead and use that swap ETH token function. And so I'm gonna need to type in coin A and put in a value of, I don't know, 2 ETH is good. And let's see what happened. So it says ERC20 transfer amount exceeds balance. So we're gonna need to increase that. And that's because like initially we just started with a couple of coins. Let's just make it like 10,000 or something. So there's like actual balance there. All right, deploy it again. Let's try it again. Pass in coin A. Okay, it seems like it worked. And now we're just gonna go ahead and check the balance. Now, it has 2 inputs. Remember, you gotta put in coin A and then the wallet that you wanna check it on. So put in the new wallet address and we should get back a pretty interesting number in Way, but it's gonna be a 1 and a lot of zeros. So let's see. And there you go. Works perfectly, works beautifully. Now, we're gonna need to do the swap the other direction. You're gonna need to do it from custom coin to ETH as well. So let's go ahead and do that now. All right, let's say you converted too much ETH and you want to convert some back. I got you. Start by creating a new function and that will call swap token to ETH, which will obviously, just like last time, take in one string that is the token name, but this time it will also take in a uint, which will be underscore amount. And then this will return, once again, a uint. Now, we're going to get started with some quick math and stuff like that. So create a new variable. It was going to be exact amount, which is going to just convert it to weight, because we'll convert it to the 18-digit version of the currency that you're passing in. So that's always useful when you work with Solidity. And then you want to go ahead, create a new variable, which is going to be the ETH amount. Now, it's going to be exact amount times the ETH value, which is just the conversion value. And then we can get into business. Now, we're going to need to make sure that the current address, so meaning the current, the contract's built-in wallet has enough ETH to transfer over. So you want to make sure that the balance is greater than or equal to the amount that is required. And if not, just throw an error message. And then after that, you're going to go ahead and get started actually transferring that money. So you want to make the message sender address payable and then transfer the required amount. Now, after that, you want to make sure at this point that the transfer was successful. And then you want to, and then last but not least, return the amount that was transferred over. Now, let's go ahead and test this out, because there's a couple of things that we haven't discussed just yet, but you're gonna find it out real soon. So let's go and do the same steps. So we're just gonna go ahead, convert some ETH, and then let's get the address. So yeah, there we go. The ETH to token was successful. However, let's go ahead and convert some of them back. So yeah, let's go with 12 coin-A's. Let's transact. And there you go, there's some sort of error. Now, don't worry about it. It just says insufficient allowance on the second line at the very end. That's something we haven't discussed yet, but that's something that we're going to address right now. So what you need to do is get the address of the coin like that. And then we're going to go ahead and interact with the coin contract itself, as you can see on the screen. Because as of right now, we are only interacting with the DEX itself. But we need to interact right now with the coin, because we're gonna need to increase the allowance. So put in your wallet address right there. Okay, right there. That's going to be your wallet address, and now you're gonna increase the amount. So that's what we need to specify now. And just to make things easy, we're going to approve the entire balance of all the coin-A's, and then now it should go through. So let's go ahead and actually hit transact. And as you can see, both of the transactions went through, and there you go. The balance just changed by 12. You can see at the very end, it says 88 and a lot of nines in front of it. So that means that our function worked perfectly in this case, and we just got it done. So with that said, let's go ahead and now enable the swapping between custom token and custom token. All right, so far we have covered 2 of the 3 main swapping methods. One, just for a quick refresh, one was ETH to custom token. 2 was custom token to ETH. Now we're gonna need to cover the custom token to custom token. So let's say you have a lot of coin-A's, but you want some coin B's and you don't want to spend ETH. You just want to convert coin A to coin B. That's what's coming up. All right, so we're going to go ahead and start up with our trustee function. And then it's going to be swap token to token, or you can name it whatever. But we're going to need 2 strings as input. So there's going to be source token name and there's going to be destination token name. And you also want to put in an amount, which is going to be a number. Now, this is going to be, once again, a public one. And we're going to need to make sure that the source token, we're going to need to make sure that we take out the amount, we take out the amount that is trying to be transferred from the source wallet, and we just store it in the contract. And then we're going to transfer over from the central wallet to the user themselves. So that's something liquidity pool would be in the real life situation, but this is going to be like a dumbed down, easier version of that. So, and now we're going to just transfer over a bunch of token B, or like destination tokens, to the sender. So once again, first line is just taking out the source token from the user's wallet, and then second is going to take the equivalent amount in a different token and then put it back into the user's wallet. And that's basically our function. So let's go ahead and deploy it, and we're gonna go ahead and swap some ETH to coin A, and then now we're gonna need to increase the balance. Okay, there you go, we got the balance. Now we're gonna need to increase the allowance, so that's something that we're gonna do, and just for simplicity's sake, approve for the entire balance. Let's go ahead and test out our function. So coin A to coin B, and let's say we just want to try pass over 10. So what we need to see now is that when we check on coin B's balance in our wallet, we should see a 10. And there you go, ladies and gentlemen. That is a perfect solution. If you see that, that is perfect. And if not, just go back, rewind, or you can just double check that the function is perfectly written, or if you've made any mistakes. That's that. Let's go ahead and keep on going. Now this is just going to be like a quick complementary function. We're just going to go ahead and double check that how much ETH is available on the contract. So it's going to be an easy, actually you should go ahead, try it out by yourself. There's no input, nothing. One liner, I think so. It's like a super easy function. Try it out by yourself, pause it now, and then if you were able to figure it out, good. If not, it's completely fine too. Let's keep on going with the solution. So it's going to return a uint, and what we're going to return is address this.balance. That's it. And that should, in theory, return how much ETH is currently stored on our contract's wallet. So let's go ahead, deploy the new contract, and let's see what we've got. It'll say 0, so that's perfect. And if you were to send some in there and convert, then it's going to be updated. But with that said, let's keep on going. All right, so now we're gonna start using truffle extension inside of our VS Code. And what you wanna do is just copy the entire contract that we just wrote, put it on your clipboard, Command-C it, and because we're gonna be copying it over. So in our VS Code, what we're gonna do is go ahead and create a new contracts folder and open up the CLI right there. And you wanna install truffle. So it's going to be a global install. If you haven't done that already, now is the time. And then you want to type in truffle in it, and that will spin up a new truffle project. Now, inside the truffle project, you want to go ahead and type in truffle create contract Uniswap, and that will create you a new contract file. And that is where you want to go ahead and paste your contract. So as you can see, definitely you have to make sure that the Solidity version is perfect, and then just paste the entire contract, and there you go. Now you might be seeing this red underscore under the OpenZeppelin package, and that's because we haven't installed it yet. So let's go ahead and fix that. So just yarn add and then paste at OpenZeppelin/contact, and once it's done, you want to right click on your Solidity file and then just hit build contracts. Now if you do not have truffle extension at this point, go back in the video. I explained it earlier how to install it and how to set it up. I'm not gonna do it again. But that is where the setup is. So if you're just skipping around, it's gonna be like somewhere in the beginning. So that's where you wanna look for it. All right, let's go ahead and continue. So you wanna click that, and then it's gonna build, and in the output, you can check how that goes. You wanna see something like successful, compiled successfully. And then next up, you wanna hit deploy. Like right click and deploy, and then select Goerli. Now we set this up as well, and this is, so don't worry about it, just go back and check it out if you haven't done that already. Now it's asking for gas price, leave it empty, just hit return on it, don't even worry about it. And then you're gonna either paste your mnemonic, or if you've already set it up, you can just use that configuration. And then if you're pasting it, it's going to do this. And then once you're done, it will go ahead and try deploy it. However, it's not gonna go through. It's like you don't see any kind of address on my screen right now. And that's because we missed out, we completely forgot the migrations file. And that's something that like we do here at Clever Programmer every single time. That is our signature. We try to deploy, and then, oh, the migrations file. So in the migrations folder, you wanna go ahead and create a new file, which will be one_deploy. And then we'll have to import the Uniswap contract. So there's going to be artifacts that require a Uniswap, and then just export the deployer. And so then you're going to be good to go. Now try again, hit deploy, and this time it's going to go through. So let's speed through that real quick. And as you can see, there is my contract address. So you want to go ahead, copy that, and then go into your Uniswap app, go into utils, and then contracts.js, close that output out, and then just create a new variable, which will be address, and then just save it there, because that's going to be something that's going to be the thing that we're going to be using. Now, if you want to double check on Etherscan, goerli.etherscan.io, paste your address in, you're going to see everything that just went through. So if you're up to this point, congratulations. Now we're going to go ahead and set up RainbowKit. All right, so you want to go into your app.js file, and we're going to import a bunch of things. So just hold on. It's going to be rainbow-me/RainbowKit/styles.css. It's going to be giving us all the styles. And then you're going to import merge from low-merge. And then this is where it's going to get started. This is where it's going to start to be mental. So we're going to need get default wallets. We're going to need RainbowKit provider. We're going to need dark theme, and we're going to need midnight theme. Actually, you can just choose between the two. We sometimes just split it. I don't know. I prefer dark theme if you're interested, but try out midnight. That's like completely black. And then dark is like dark gray. So the more you know. All these are coming from RainbowKit. Now, we're going to need a bunch of things from WagMe, I believe, is what's coming up. So that's chain, configure chain, create client, and WagMe config. All this is coming from WagMe. And then we're going to import Infura provider from WagMe/provider/Infura. And that is basically it. Now, up until this point, you need to import everything. We're going to be using all of it. So just pause here for a quick sec, double check you have everything, and let's keep on going then. Now, we're going to destructure chains and provider from configured chains, and we're going to have two arrays in here. So in the first array, we're just going to put in chain.goerli. That means that this app is only going to be running on the Goerli chain. Nothing else is going to work here. And then for that, we're going to be using the Infura provider, where we need to put in an API key. Now, we have it somewhere. If you haven't done that already, just place it in an env file, and then you don't actually have to expose it to the browser. That's a good thing about it. You can just go with Infura API key. You don't have to do next public, but as you can see, that is how you get your API key. So if you haven't done that already, now is the time to do it. And so there you go. All right, next up, we're going to be setting up the connectors for our wallet connection, and that's going to be using get default wallets from WagMe. Now we need to pass in app name, that is going to be Uniswap. You can pass in whatever, and then you're going to need to pass in chains. And then next up, we're going to have a WagMe client that will use create client, and we're going to need to pass in a couple things here. So we're going to need to pass in auto connect. You can either set it to true or false. I prefer it to be true, but for this build, we just used false for whatever reason. And then you want to pass in connectors and the provider. And with that, all the setup is ready. And then one last thing to set up is going to be, we're going to make sure we're going to create a my theme, which will merge midnight theme. And we're going to override a couple of colors. So we're going to say, we're going to have an accent color of that. And this is like completely optional. This is just elements. So there you have it, accented color foreground and accent color. And now we're going to wrap our app in between WagMe config and where we're going to need to pass in WagMe client. It's like context. These are like contexts for our app to be able to access this. And then we're going to import we're going to wrap the RainbowKit provider with the chains and the theme, and then just pass in the app. And that is basically it. Now we're going to go ahead and actually render the connect button to our screen. All right, let's actually go ahead and render out that connect button. And so this is going to be a quick one. What you want to do is go into your header file inside your components folder, and then go ahead and import connect button from RainbowKit, just like that. And then we already, as you can see, we have it commented out. That's the place where you want to put it in as a component. So that's literally all we do. Once that's there, it's going to show up on the top right corner. And now let's actually check it out. So there you go. literally pre-set up by RainbowKit, so you can already use it. And once you hit Metamask, it's going to work perfectly. So that's it. All right, let's go ahead and set up all the contract builders. So we're going to be importing a couple of things here. So first of all, we're going to need ethers. Then we're going to need Uniswap API from utils/Uniswap API. Yeah, uniswap.json. And then we're going to do the exact same for the custom token. These are coming with the build. All right. Now, next up, we're gonna need two functions that we're immediately straight away going to export. So let's not waste any time on that. First, we're gonna have a token contract that we're gonna export, and that'll take in an address. And then we're going to generate a provider using ethers.providers.web3 provider, and using the window Ethereum. And what is window Ethereum? That's basically the code that is being injected by Metamask. Now, next up, we're going to use that. We're just going to go ahead and destructure Ethereum from window. And if it actually exists, meaning the user has installed Metamask, we're going to use that to generate first a signer. So we're going to say provider.getSigner. And all these are going to be like, this is a lot of like setup and prep and whatever, but this is ultimately going to be like completely needed in order to be able to interact with the contract. All right, so we're going to generate a contract reader, and it's going to be new ethers.contract and passing address, contract API, and the signer itself, and then just return that bad boy. And that's pretty much the first one. Now, we're going to repeat this exact same process for the Uniswap contract itself, so the DEX. So the first two lines are copy paste immediately, if statement, copy paste, yada yada. And the only two things that are going to change are going to be the address, because there's only one address in this scenario, and that's going to be the DEX address. And then which API are we passing in? So in this case, it's going to be the Uniswap API.API. And then we're just passing the same signer that we created up above, and then return the contract reader. So that's pretty much it. Now we're going to set up a couple more helper functions and then actually put things into motion. All right, so these are going to be two functions that we're going to be setting up just so we can convert between Ether and Way. So we're going to import ethers from ethers, and then we're going to use that to set up two functions. So we're going to have one function that will be two-way, and that will take in an amount, and then that'll take in a decimals, but default value is going to be 18. And then we're just going to say const two-way ether.utils.parse units, and that's just something that like comes from ethers, and then passing the amount, and then passing decimals, and then we're just going to return that. Now, and then we're just going to return that as a string. That is the first one, and then the second one, I'll let you figure it out by yourself, but it's going to be on the same analogy. The only difference, we're going to be passing in way here, and then we're going to need ETH. So I'm going to go ahead and continue now. So we're going to say it's going to be 2 ETH, and once again, we're going to pass in an amount. Decimals is going to be 18, usual utils.format units, and then we're going to say, we're going to go the ETH same. We're going to type the exact same thing. All right, that being said, we are actually going to go ahead and start implementing the ETH to coin functionality. All right, so let's finally swap from ETH to your custom tokens that we have worked so hard for. All right, so you want to go into your queries.js file and then import a couple of things. So big number and ethers from ethers, first of all, and then you want to import contract and token contract from the contract file that we set up earlier. So that's the contract interaction interfaces functions. I don't remember them completely, but that's what's basically going to allow you to actually interface with your contract. And then next up, we're going to import 2 ETH and 2 Way, so the other two helper functions that we just created. And so here we're going to have the swap to ETH function, which will require token name and amount. And as I always say, use try-catch functions, console log the error out. And then we're going to convert the amount to Way, because once again, Solidity only works with Way. We're going to use the contract function that we set up earlier to generate a contract object for Uniswap for us. And then we're going to use that to actually handle the transaction itself. So we're going to say contract object that swap ETH to token and pass in token name and TX, which is the Way amount of the ETH amount the user passed in. And then we're going to go ahead and generate a receipt by waiting for that data and then return it once it's done. So that's basically it for that file. Now you want to go ahead and go over to swap component and scroll down to wherever you see functions for contract functionality here. And then you want to put in, create a new function that'll heavily rely on our setup of the front end. So we're going to create a perform swap function that's going to be an async function. And we're going to, before we do anything, set transaction pending, true. All right. And then we're going to go ahead and generate a receipt. We're going to go ahead and create a new variable that we're going to call receipt. And then using everything that we set up earlier, just type in if source token equals ETH and destination token doesn't equal ETH, and you would just want to invoke, and you want to wait for the swap ETH to token function and then put in destination token and input value. And like I said, this whole thing is heavily relying on the front end that we already set up for your convenience. Now, you definitely want to make sure that a function is actually getting called. So we're going to create a new function that we'll call handle swap. It's actually on my screen on line 73. There was a little bit of scrolling, so just wanted to help you out with that. Now, here it's a little repetitive, but we're just going to double check that everything is good to go there and then call the function once everything is ready. Now, on my screen on line 140, we're going to pass in that function. And what that basically does is that will fire up this function and whenever you hit the swap button, which you currently cannot see because the wallet is not connected to the app, but I'm going to show you just now. Let's go to this app, put in a value there, and then we're going to need to select a token. So that's going to be coin A, and you got to connect your wallet. So that's something you got to do. And then it didn't turn blue. So there's some sort of error going on here. Let's actually go ahead and figure that out. Now, as you can see on line 16, we have imported use account from WAGMI, and that basically is just going to help us. That's just going to help us to check whether wallet is connected or not. So just update it on line 61, and you're just going to destructure address from use account, and that itself is going to take care of this whole thing. The wallet is connected, and then there you go. Now there's your swap button, and then confirm that transaction, speed it up a little bit because that never hurt. And there you go. You can try it with another amount and it's going to work perfectly again. So there it is. That is your function. Now we're going to go ahead and fetch balances of each token and render them out on the screen. All right, ladies and gentlemen, let's go ahead and fetch those balances. It's going to be a little bit of a longer thing, but yeah, that's where it's going to go. Now, you want to go into your header file because everything is going to happen in our header, and we're going to import a few things. So start with use account from WAGMI, and then we're going to import token balance from token balance. And then we're going to create a new use state, which is going to be token balance, and it's going to start out as a complete nothingness. Now, you want to extract address from, or destructure address from use account. And then we're just going to go ahead and kick things off with a use effect, which we're going to fire off every single time once the address changes. That is important because if you connect a different wallet to the app, you want to see the updated balances inside that wallet and not the previous one. So this is super important. Now we're going to go ahead and we're going to update the use state with a bunch of JSX code in there. So we're going to use the token balance component and pass in coin A and then the wallet address. So we're going to repeat this a couple of times. So like because we have 3 custom coins, we're gonna do this 3 times. And by the way, those coin names are going to be strings. So you want to make sure you have coin ABC and then 3 times the wallet address as in the address. All right, next up, you want to have an if statement and make sure that if the user haven't connected their wallets, then you want to punch out a little bit of a notification for them. So we're going to go ahead and set that up right now. So it's going to be a toast wallet, and it's just going to be like a toast error, and we're going to be like, yo, connect your wallet or something like that. It's going to be there for 2 seconds, and that's basically how it's going to look like. You can see it on the right. Okay, so we just connected our wallet, and now you're going to go ahead and we actually have to render those components out. So render out, just put the token balance component and render it out right there, but throw some sort of error. Okay, so let's actually go into that token balance component. Let's see what's going on in there. So we're going to need to create a couple things. We're going to need to have a balance use state, and we're going to need to have a copy icon use state. So there's a few things that we need to specify here, and that will just be a icon that we already imported for you. So that's going to be clipboard icon, and then we're gonna have multiple states. So we're gonna have a transaction pending, and we're gonna have a not pending, and we're just gonna kick them off based on whatever is suitable for the situation. And then you also want to have a token address over there. And by the way, the balance is going to start out as like a dash string, basically. All right, now we're gonna have 2 notifiers set up. So that one is going to be an error, and it's just going to be like a toast error, just like the one before, but this time it's going to go for 6 seconds. And that's, by the way, in milliseconds, so that's why it's 6,000. And then we're going to have a success message, or like a success toast, where we're going to say transaction complete. And I mean, you can go ahead and set up a duration for that too, honestly. So go ahead, create a new function, which is going to be fetch token balance, and that's going to be, and then we're just going to kick things off with invoking the get token balance function, which we imported earlier, or which we're going to set up in a little bit. And you're going to need to pass in a name and wallet address for that. And then we're going to also need to format the balance, and then set that balance, or set that formatted balance to the state itself out. So there's going to be, that's how it's going to look like in a little bit. That's the component that we're gonna make we're gonna have to fill up with the good data. All right, so go into your queries.js file, and we're gonna go ahead and set up get token balance function. And so we're gonna need to call the contract there. So we're gonna need to set up the contract object, and just like before, use the get balance function from a method from that contract balance, and then create a new variable and then return it. And that should basically get it every single time. And then you're going to need another one, which is going to be get token address. And once again, just go ahead, try it out by yourself. Like every single time we create a new function, I want you to go ahead from now on, because it's going to be a lot of repetition. So try it out by yourself and see if it works, and then just come back for the solution. So try catch, console log the error out, and then we're gonna create the usual contract object, and then the usual way, just call on the get token address func method. Now, everything that we just created, we're gonna go ahead and now import from that file. So get token address and get token balance. And then we're also going to set up a new function, which is going to be fetching, which is going to use the get token address function that we just set up. So it's going to be fetch token address. It's going to be an async function. Use that, and then whatever that thing returns, we're going to set it to the state. And then we're going to go ahead and set up a use effect that will run again and again whenever name and the wallet address changes. And if both of them exist, then we're gonna fetch the token balances, and then we're also gonna fetch the token addresses. And if not either of them don't exist, we're just gonna set everything back to their normal regular or like the initial value. And then it says ethers doesn't exist. So let's go ahead, fix that, import ethers from ethers, and that should be good pretty much. Now, if you scroll down on my screen, it's line 40, but on your screen, but on your page, it might be something different. So just check out where it's at. We have a hard-coded balance there, but we should go ahead and now fix that. So let's see what happens there. And there you go, ladies and gentlemen. As you can see, our previous two swaps were successful because you can see the 30 coin A and the 20 coin B transactions that we did there. So that's basically it. Now we're going to go ahead and display a success toast whenever the transaction succeeds. All right, let's just go ahead and set it up. So go back to your swap component. And as you can see, we already set everything up for success. So now we're just going to invoke everything. So go to your perform swap function. We should have set the set transaction pending state to false once it's done. And then if the transaction results in a receipt and that receipt doesn't have a transaction hash property, then you want to go ahead and notify error. So fire that off and then pass in receipt so everybody knows what's happening. Else, just notify success, and that should basically be pretty successful. So let's go ahead and test it out. So let's do some transactions over there, hit confirm, and let's see what we got. Let's see if it works. Let's speed that bad boy up, and any moment now. And there you go, there is your toast message. And also, as you can see on the right hand side, once I connect my wallet, coin B now has 60. So the transaction definitely went through, and now we have proven that it did go through. All right, let's go ahead and now set up the swapping from token, or like from custom ERC20 token to ETH. So what we're going to be doing here is, first of all, close out everything. We don't need a bunch of things. Go into your queries.js file, and we're going to set up two functions, but let's start with the first one now. So that's going to be swap token to ETH. Now, it's going to be an async function that takes in token name and amount, and we're just going to do the usual try catch, console log error, yada yada. Create your contract object, and then what we're going to do is use that contract object to swap token to ETH, basically call that function of the contract. So we're going to pass in the usual stuff to the way converted amount of the amount you want to convert, and then the token name. Now, it's going to be the same thing whenever the receipt shows up, wait for it, and then return the receipt. Now, as you remember, we're going to need to pre-approve the amount to be transferred. So let's do that now. That's going to be the second function. So that's going to be increase allowance. And so once again, we're going to pass in the token name and the amount, and then we're going to do the usual try catch, console log the error. And there's going to be a little bit of a trick here now. So I want you to listen closely. So we're going to what we're going to do is we're going to determine the address of the specific coin that we're going to need. And then we're going to use that address to generate a new contract object. And we're going to use that to increase the allowance. All right. So there's going to be two contract objects here, and we're going to be interacting with two contracts in the same function. So that's how. Let's continue. So we're going to use the Uniswap contract to get the address of the custom token. So we're going to pass in token name, and then we're going to go ahead and generate a token contract object using that address that we just generated so that we can increase the allowance. And so we're going to do that right now. So using that, we're going to go ahead and call approve. And so what's happening now is the approve function works in a way where you pass in who can interact with this wallet, or who can interact with this coin, and how much are you allowing them to interact with this coin. So we're going to need to pass in two things. One of them is going to be the Uniswap address, and the other one is going to be the way amount of the amount, or like the way converted amount of the amount you want to convert. And with that being said, we're pretty much good to go here. All right, now let's actually connect this with our front end. So we're gonna go into our swap component, and in the perform swap function, there is that if statement. So you're gonna add a else clause after it. So we're gonna say else if the source token is not ETH, but the destination token is. This is what we're gonna do. So now we're gonna generate the receipt based on that, and we're going to call the swap token to ETH function. And now we're going to create the increase allowance function. So let's go ahead and do that. So transaction pending has to be true. And then we're gonna use the function that we just built and then invoked it and invoking and then pass in source token and input value. And after that, once it's good to go, might as well turn off the loading screen. And so inside of handle swap, I'm going to turn on the loading screen again. And then you want to check whether the wallet has some sort of allowance on the source token for the amount that you are trying to convert back to ETH. Oh, there's an error. I'm going to make it async. Okay, that's fine. And after that, we're good with loading. So let's actually remove that. And then if the result is valid, and actually call the perform swap function. And if not, if the user doesn't have allowance, now we gotta call the handle insufficient allowance function. And to do that, what we're gonna do, like we already set that up ahead of time. Now we're going to just switch out the swap button to a different button. And so let's go ahead and do that. That's on my screen. That's line 162. And there is a swap button text, whether if it's an increase allowance or not. And if it is, then we're going to call the handle increase allowance function. Now, let's go ahead and try it out. Let's see how this actually works. So we're going to use 20 coin A's and then just swap back into ETH. And let's see what happens. There's some interesting things going on around in the background, so that's something. So we apparently don't really have the has wallet allowance function. But that's completely fine because we're going to go ahead and build it now. Let's see what can we do here. So we're going to pass an owner. We're going to need the token name and the amount. And we're going to use the usual try catch, console log the error. That's fine. And then we're going to use the Uniswap contract to generate our contract object. And then we're going to have an address. Obviously, once again, we got to fetch the token address to get everything. And then using the token contract, we're going to double check the allowance. So we're literally just gonna fetch it. So we're gonna pass in owner, and then we're gonna pass in the Uniswap address, and then we're going to convert it into a regular human number. So we're gonna say that's a bunch of things going on there. So basically, what's happening is we're gonna get the way amount and then generate a big number from it. And then we're going to use that to generate a string that we'll be able to work with later on. So just go ahead, copy that, and then feel free to spend some time understanding what is happening there. And then now we're gonna go ahead and return the result and also export the function because we need to use it in our swap component. So let's go ahead and try it out again. So if we click swap, it says, oops, insufficient allowance. So we're going to need to increase it. So we're going to go ahead, click that. Okay, there's some interesting things happening here again. So it says API.map is not a function. We might have made a mistake earlier on. Yeah, there it is. So you want to double check that every single time when you're generating a contract reader, you import the JSON and then .api, and that's what you're trying to interface with because there's a bunch of stuff that you don't need. So let's go ahead, test this out again. So refresh real quick, connect your wallet, and then I'm gonna say 30. Okay, insufficient allowance, we've seen that. And there you go, give access. Let's wait for it to go through, speed it up if we need to, and then refresh real quick, connect your wallet again. And then now it says swap, and if you click it, you're gonna approve the transaction itself, not the allowance. So we should be pretty much good to go soon. So let's see how that goes. Perfect. It says transaction completed. So technically we should be good. Let's just refresh real quick. So connect that. And now you see that the values have been updated. So that's basically it. Now we're just going to implement token to token and we're good to go. All right, so to make this work, we're going to need to go into our queries.js file, and it's going to be super simple. It's going to be super fast. So just create a new function, swap token to token, pass in source token and destination token and amount, and the usual try catch console log the error, because that's usually helpful to see what went wrong. And now you're going to generate the contract object as usual. You can, once again, try it by yourself. But if it doesn't, if you're not that experienced, that's fine too, which is going to be basically the response of the swap function. And then just pass in everything that we got. Obviously, make sure you convert the amount to weight. And next up, you want to go ahead and generate the receipt and return it. Now, if you don't export the function, it's not going to work elsewhere. So go back to your swap component after you've done that. End of perform swaps if statement, you want to have an else clause, which has no other conditions. Basically, it just in the first two, we made sure that everything is accounted for. So now this is the only option to do, or the only option to have. And now what you want to do is generate the local receipt for that, or update the receipt variable for that, and then call the swap token to token function from the file that we just, from the queries file, and then pass in everything. That function is going. Go ahead and see what do we need. So everything should be ready to go pretty much. So let's see what do we got. Let's turn 30 coin A's and just swap them over to coin B. Let's see if that works. So let's hit swap. And okay, we got to increase the allowance. That's perfect. That's fine. Okay, hit confirm. Let's see if it works, and we can just speed it up, see if it's good to go. And after that's done, we can actually go ahead. Now that we have the allowance, we can now actually go ahead and do the swap. And once you confirm the transaction, it should go through pretty fast. Transaction completed. And there you go, there you have it. Your coin A and coin B is updated. So ladies and gentlemen, that is it. It is a fully functional Uniswap DEX that is able to convert between random ERC20 tokens. Use it. You can literally, actually, factually use this, and you can transfer your ETH into custom coins and your custom coins back to ETH, and then custom coins between custom coins, and then all that kind of stuff. So you can have basically your own trading bot. I'm not saying you should be doing that, but with a little enhancement, you can automate that stuff. So there you go. That's pretty much it. And I hope you got some value out of this tutorial. And with that said, I'll see you in the next one.